Hello. Yeah, I'm going to do this problem. It's a nice problem here. This is 2.4.37. So we want to find the interest earned, right, on $10,000 invested for 7 years at 7% interest compounded in the following ways. Okay, so let's write down the first one annually first. I'll call that P0. Okay, so no, P1 for compounding once is, well, here's what the principal would be, and then I'll subtract 10,000. So you get 10,000, right? And then what you do is you multiply that by 1 plus, you get 7% interest, 0.07. I'm going to divide by 1. It looks odd, but I want to do this for a reason. And then you do that, you compound it, 7 times once each year. And that's what we come up with, right? It's, 10,000 times 1.07 to the 7th power. That's the principal. Okay, and I'll leave a little room there here. Well, let's just calculate it. What the heck? I want you to see what's going on here. Here, I'll delete that. Okay, so here it is, right? And you would get, 16,000 and, hold on, what is it? Okay, I have it on the side, but that becomes $57.81. Okay. So that's what the principal would be worth if you compounded it annually. So for semi-annually or twice a year, I'll call that P2. It's a similar formula, but what you can do is you get, the game is the idea of compounding is that you get half the interest, right? But you get it twice as often, so that's 0.07 divided by 2. But then since you're compounding it every, twice a year, that means you get 7 times 2 here, right, or 14. And let's see if that has any effect on the calculation. Well, let's see. That means that becomes a 2, and this becomes a 2. Okay, so as we can see, we get a little bit more. We get 16,186 and 95 cents. So it went up a little bit there. Okay, and that's not the interest that you receive. That would be the new principal after 7 years, compounded twice a year. Okay, and similarly, if we go on to, let's see, quarterly, that means 4 times a year. We just continue the process. Okay, so P4, I guess, let's see what else we're going to find. And then we want monthly, that's P12, right, 12 times a year. And then we are going to write down the one for continuously, which is, I'll call it P infinity, and that's sort of the limit of this process, letting your compounding, the number of times you compound, go to infinity. Okay, so then you just follow the pattern here. In this case, it's 0.07 divided by 4, but we get 7 times 4 compounding periods. And I'll just see what happens. What you'll see is that the principal should be going up. So the more often you compound, the larger your principal will be. And that's why it's important, I guess, to have a well-defined system in place when you're running a financial institution, so there's no confusion. So here's the next one, and 7%, but only 1/12 of that a year, but now we get to compound it 12 times more. Okay, and if we do that, we end up with, where is it? Okay, we end up with, here, I'll put a 12 there. Oh, looks like I got an email. And then another 12. And there you can see it goes up again to the following, and we would get 16,299 94. So let's see what happens when we get to the, well, continuously it's this. It's 10,000 times our number e to the 0.07 times the time, which is 7 years. So notice the form of the expression changes because it's we had to take a limit there, and so that's makes it look a little different. Oh, hold on here. Okay, let's see if I can type that into my device here. So we want to put down 10,000. Let's clear the whole thing. So it's 10,000 times e to the 0.07 times, oops, gosh darn it. Here, I gotta keep this up here, hold on. 0.07, I'm inside the bracket here, times 7. Okay, let's see, that should be, yeah, and there's the limit value, or if we compound continuously, we get, what is it? Okay, we get $16,323.16. Now, of course, to answer the question, for each of these we would have to subtract 10,000 to calculate the amount of interest. So I'll just do this one, and then you can do the others. Okay, so the amount of interest, oops, yeah, okay. So the amount of interest you would get for the continuous case would be $6,323.16. So, okay, I hope this helps and sheds a little bit light on this idea of compounding. So, thank you. Bye.